This meeting is being recorded.
In section 17.6, we're going to look at reactions that occur at the site called the benzylic position. So if you recall, this structure here is benzene, and when we have a methyl group or a carbon that extends from the benzene ring, at the end, we would refer to that as the benzylic position. So in this structure here, that's what is highlighted and what I just overlapped there. Both of these are considered benzylic positions. So if we looked at aromatic rings down below, we recall that both aromatic rings and alkyl groups are not easily oxidized. So we have our sodium chromate and the reagents used to prepare chromic acid here that can oxidize other species, other types of compounds, but we could not perform this type of reaction with benzene or any aromatic rings or alkyl groups in general. But if we have a substituted benzene and we have that benzylic position available, they are readily oxidized by chromic acid. So again, we use these reagents to prepare chromic acid, and we can oxidize the benzylic position here. So we have this carboxylic acid generated here by oxidation at the benzylic position. So we do need at the benzylic position at least one proton in order for that site to undergo oxidation. So we see here a quaternary carbon. So then again, we would not be able to oxidize this substituted benzene at the benzylic position. We can also use permanganate as an oxidizing agent, much like we saw here with chromic acid. So permanganate, again, we can generate this benzylate salt here as an intermediate with potassium permanganate and heat in aqueous solution. And then after an acid workup in this step, we can generate that same product that we saw previously after oxidation occurs. We can also perform a free radical bromination at a benzylic position. These are similar to allylic positions, if you recall, right? So at the benzylic position here, using that N-bromosuccinimide, NBS, and heat, we can create this benzylic bromide. And it's noted down here that they can be useful as synthetic intermediates. Such as we see here. So we have our benzylic bromide shown above, and it is at this site here. We see it's a tertiary substrate, so it would undergo an SN1 substitution. So we can create this alcohol here. And an unhindered benzylic bromide, such as this primary site here, this can undergo SN2 substitution to produce this alcohol shown down here. So again, these benzylic bromides can be very useful in synthetic processes. They can also be used instead of just substitution reactions for elimination. And again, we see with that tertiary substrate, we can use sodium ethoxide, a strong base here, and perform an E2 reaction. Or now that we have this substitution reaction occur after we perform the SN1 reaction on the previous slide, we could then do an E1 elimination shown here using concentrated sulfuric acid. And note, both of these would produce the same product, either through an E2 or E1 mechanism. So this slide shows a summary of all of the reactions that you should familiarize yourself with at the benzylic position. So everything from radical bromination, oxidation, substitution, and elimination.